Number 2, we're just going to identify which methods work. Notice we do not need to solve, we just need to identify which ones work. Okay, so starting with part A, I'm just going to kind of go through the list. I'm going to check to see if this factors. Does anything multiply to 8 and add to -6? That's -4 and -2, which means factoring would work for us. Taking a square root would not be a good choice because I have this -6x in here. That x is not being squared, so that wouldn't be a good choice. For completing the square, I just need to check if a equals 1 and b is even. I have no coefficient for an x squared, so a equals 1. B is -6, which means b is even, so we can complete the square. And quadratic formula is always going to work. So I'm going to put quadratic formula. Okay, we're just going to keep going through that same thing. Okay, part B, we're going to see if this factors. Does anything multiply to 24 but add to -11? -3, -8. Nailed it. So factoring. I'm not going to take a square root because I have this -11x here. I'm not going to complete the square because a does not equal 1, a is 2, and b is odd. So the only other one I would use is quadratic formula. Part C, I'm going to say factoring because I'm hoping you recognize this as a difference of squares, meaning I could factor that to be x plus 4, x minus 4. So factoring, I could use a square root on this one because the only x I have is being squared. So that would look like adding 16 and then square rooting both sides. We're not going to complete the square on this one because we're missing the middle term. And if we're missing the middle term, I would suggest not completing the square. And so the other one we could use is quadratic formula. Okay, part D. Does anything multiply to 15 but add to 12? No, so we're not going to factor. I'm not going to square root because of this -12x here. The x is not squared, so we won't square root. I can complete the square because a is 1 and b is even. And of course we can use quadratic formula. Okay, part E. I tell you right now, that's a square root. Because I have the x in parentheses being squared, no other x's. So I'm not going to factor, and I'm not going to complete the square. And we're actually not even going to use quadratic formula on this one. Ooh, snap. Because it's not in standard form. And so part E, we could only do that by taking square root. Okay, just a note there, like, if I distributed it, we could use other methods, but just in that format, square rooting is the only one we would use. And my last one, you can see, does anything multiply to get -20, but add to 5? 1, 20, 2, 10, 4, 5. No. Okay, so not factoring. I'm not going to square root because I have a 5x. I'm not going to complete the square because a does not equal 1. And so that just leaves quadratic formula. Okay, something to point out is all these have various methods you can use. And like, for example, part A, factoring complete the square quadratic, no method is more correct than the other. And so if you're wondering like, well, which one should I use? The answer is use the one that's easiest for you. For me, factoring is the easiest, and so that's the one I lean on. I enjoy completing the square, and so I do that as well. But if you just like, maybe you like completing the square more than factoring, then go for that. So here, and also read the directions to see what they want you to do. That's really important. If it tells you to factor, you should solve by factoring. Or if it tells you to complete the square, you should solve by completing the square. In this situation, we can solve whichever method we want, which means the world is your oyster. So I'm going to look at part A here, and in my opinion, the easiest way, I see just an x squared over here. So I think solving by square root is a great idea. And so I'm just going to subtract by 25. And now I can square root it. Plus or minus, the square root of 25 is 5, but it was a negative, so it's imaginary. So yeah, x equals plus or minus 5i. If you wanted to write that as two answers, it'd be 5i and negative 5i. Okay. Looking at part B, I can either go ahead and complete the square right now, or I can try to see if it's going to factor. If I want it to factor, I'm going to have to set this equal to 0 first. 16x minus 15 equals 0. Does anything multiply to negative 15 but add to 16? I think 15 and 1, but those both have to be positive, and this needs to multiply to be negative. So it turns out this doesn't factor. And so I'm just going to go ahead and complete the square on this. So I'm going to add the 8. All right, and I'm going to take my middle and divide it by 2. Nope, that should be a 16. Let's try that again. 16 divided by 2 is 8. Now we're going to square it to get 64. I'm going to add that in both sides. Let's see, that gets us 79. And over here, now that I have a perfect square trinomial, I can rewrite it as a squared binomial to get x plus 8 squared equals 79. Take the square root, x plus 8 equals plus or minus, let's see, does 79 have any factors? I don't think so. 9 divided, yeah, okay. So we're just going to leave that as square root 79. And now I subtract 8. Cool. Okay, part C. I know I'm not going to complete the square right away because a equals 2. Which means I'm going to add the 3 over because everything else pretty much wants it to be equal to 0. Okay, I'm going to try factoring because I always try factoring first. That's a personal preference. That should be 30. Okay, let's try that again. What multiplies to 30 but adds to negative 13? Negative 10 and negative 3. Nice. A does not equal 1 here, so I can't use the shortcut. So I'm just going to substitute both the negative 10 and the negative 3 in for the negative 13. And now I can factor by grouping. The GCF of the left side is 2x times x minus 5. The GCF of the right side is negative 3. And then I factor that out and get x minus 5. So now when I factor out x minus 5 from everything, I'm left with 2x minus 3. And because of the zero product property, I have two things that multiply to be 0, so that tells me that either x minus 5 is 0, which gets me a solution of x equals 5, or I know that 2x minus 3 equals 0, and I get x equals 3/2. If you would rather do that with quadratic formula, you can totally do that. Okay, part D, I'm going to start by getting this in standard form. I see a GCF of 2, so I'm just going to go for it and see if that helps me out. And I'm going to check to see if it factors. Does anything multiply to 6 but add to -5? Be a -2 and a -3. And because my x squared doesn't have a coefficient in front of it anymore, we can use the shortcut, bless up. So I can go x minus 2 times x minus 3 equals 0. And because of the zero product property, I have a bunch of stuff multiplying to be 0, which means that either x minus 2 is 0 or x minus 3 is 0. So I get x is positive 2 and x is positive 3 as my solutions. Okay. Part E, I can already tell that I can complete the square on this one because a equals 1, b is even. So I think I'm just going to go for complete the square because I don't feel like adding it over to see if it factors again. Let's see. So I'm going to start by subtracting the 25. You might be noticing that I personally avoid quadratic formula if I can, because I just don't want to deal with all the steps of simplification. Okay, so to find the value that completes the square, take -6 divided by 2 and get -3. -3 squared is 9. So add 9. So it should be -38 plus 9 is -29. Now that I have a perfect square trinomial on the left squared, I can rewrite it as a squared binomial. That would be x minus 3. And just a reminder that minus 3 is coming from taking the middle term and dividing it by 2. Now I can square root. It's minus 3 equals plus or minus, square root, -29. 29 is a prime number, but I see the negative, which means this is going to be I, and then square root 29. And I can add 3. And I get 3 plus or minus I squared root 29. So literally, I've just done factoring and complete the square for most of these. Looks like part A I did, a square root. So I'd hate to leave you without quadratic formula. So let's do some quadratic formula. I'm going to start by getting this in standard form. X squared plus 11x minus 20 equals 0. And I'm just going to write down my quadratic formula for reference over here. I'm hoping you have this memorized by now. And if you don't, you should. Right, A equals 1, B equals 11, C equals -20. So x equals -b, since b is 11, -b is -11. Plus or minus the square root of 11 squared minus 4 times a, which is 1, times c, which is -20, all over 2 times 1. -11 plus or minus, let's see, that's 121. -4 times -20 is plus 80 over 2. 201 over 2. Okay, so now we have to check to see if 201 is divisible by anything. You can just check in your calculator. So it looks like 201 breaks up into 3 into 67. I think 67 is prime. Yeah. So cool. That means that's it. Okay. I hope this was helpful to know which method to use. And I'm just going to write down once again. Maybe I should have done this as I went. This one factors, so I factored it. This one, A was equal to 1 and B is even. This one had just an x squared. And this one the same thing, A was equal to 1, B is even. So that's kind of like, why did I choose those methods? That's why. I hope this was helpful in determining which method to use. If you have questions, please reach out to your teacher.